Welcome. So this video is just quickly highlight a couple basic things, get you started for our linear algebra class. So first off, I am Dr. Bailey. So I'm going to go through an introduction of the class, some learning outcomes. I don't want to spend a lot of time. Your textbook, our grading, and a little bit of a summary, and just things to help you be successful in the class. So first off, we're going to do linear algebra. Now, linear algebra is actually the basis of a lot of computer science. It's really important in machine learning, electrical engineering, mechanical engineering. Uh, we use it in a lot of different places. If you've taken Calculus 3, you've actually used some of the concepts, some of the super basic concepts of linear algebra. But we're going to take it much further, and we're going to talk about why they work a little bit more. We'll get into, I'll maybe touch on some applications in class. I'm not going to test on it a lot just because there is a huge variety of different students in the class in terms of majors. Despite there's only so a few 12 of you. So I think at the time I'm recording this. So because there's only 12, but we have like 4 different majors, it's kind of hard to have applications that meet everybody. So I'm not going to get into that, but I will kind of hint at them, and I will tell you right now, I guarantee you this is applicable in your field. It is a huge thing. Linear algebra is like one of the awesomest things in the world, and I absolutely love it. So here's the learning outcomes set by the state of Texas for this class. That means the governing board for all the higher education in Texas has said that these are the 7 things that students will be able to do. Sorry, skipped ahead on me. And we're going to talk about these. We'll get more, but you can read through them. They're in the syllabus. Last thing got cut off. It's applications of inner products and understanding inner product spaces and so forth. Again, we'll get to that and how norms are affected and so forth. But a big thing I'm just going to point out here is matrix. You'll see the word matrix, vector. Matrices and vectors are the basis for linear algebra. If you watch the other videos for week 1, you'll get to know that we do a lot of things just with vectors. And we're gonna spend a lot of time on matrices and reduction of matrices before we get into some other things. The truth is, a lot of this is just related and connected. We're gonna also talk about eigenvalues and eigenvectors, linear transformation. It's a really huge thing. There's a lot of different stuff. We're gonna cruise through that. So for me, I'm Dr. Bailey. I have my PhD in math. I also have been teaching here for about 5 years. My research area is predominantly graph theory, combinatorics, math education. I also do data science and data analysis. I do statistical analysis. And just a side note, because this is a linear algebra class, my very first published paper was actually on linear algebra in an area of graph theory. We were using it with one of my linear algebra professors. He wanted to do something. And so he brought me in as the graph theory expert on how we can bridge, because the areas of graph theory, actually, there's problems with graph theory that can only be solved in linear algebra, and linear algebra problems can only be solved in graph theory. So it's really fun to see how different things. For fun, I am a power lifter. I love to lift really big things, and so forth. So that's me. Feel free to ask more questions. Let's get to something else that's important to mention. The prerequisite for this class is calculus. I think I may have checked that in wrong. That should be 2414. It should be Calc 2 with a C or better. However, I'm going to just be honest with you. You really don't use Calc 1 or Calc 2 that much in this class. We do use algebra, so you do actually need to know your algebra, and you will be actually using concepts. I will refer back to calculus concepts like derivatives and how they're linear and what that really means, because it's a common terminology in linear algebra. Your textbook it's linear algebra and its applications, 6th edition. You only need the MyMathLab license, which should be purchased already. So this semester is the first semester that the university is doing this new weird thing with where they're supposed to be providing you with textbooks that you automatically pay for, that they're automatically built into your bill for all your classes. So your MyMathLab should be already paid for. You should already have that. I don't know where. So I'm just being honest, like this is the first time I'm with you. I do know there should be, the university told me to create a course materials tab inside of Canvas, and you can look there. And then also there's an Access Pearson where you can sign up for the course. If you're signing up and you don't yet have your sign up thing, you can at least click a temporary license and they'll give you 2 weeks while we figure out this whole access code, if that's still missing, but that's only temporary. We are going to have to make sure you have the access code for the long term of the semester. Another quick thing I'll just mention, because it'll come up, but I'll mention the first day again, is calculators. You do not need a calculator for this class. If you would like to use a basic scientific calculator, a simple 4-function calculator on your quiz, on your quizzes, and I'll talk about those, sure, but no graphing calculators. I won't allow those. To be honest, no one actually uses those in the real world. If you do high-end linear algebra computations, you're using a computer, but you also need to know how to do these things because you have to write the algorithms and then figure out how to optimize it. That applies to both electrical engineers, mechanical, mathematicians, all of you. You're at some level understanding how these things work to understand how they're related to different concepts. And then what happens when we change something? Can I still perform that same operation, or how's that operation going to have an impact? So there's a lot of things we're going to get into. So calculator wise, you don't need a calculator. If you don't have a calculator, fine. If you really want a calculator because you feel horrible with your arithmetic, even though it's not really what I'm grading you on, go buy a $5 calculator from Walmart or dollar store or whatever, and that should be fine. Couple key things to point out. This class is an 8-week course. That means we are half of the semester. That doesn't even cover half the material. Instead, it means we go double time. So we're going to go real fast. I'm just going to be honest with you. This is a movement the university is in the middle of transitioning to. Texarkana College down the street has already transitioned all their classes to 8-week. And I think in many ways that's better because then you can take like 2 really high intense 8-week classes and then take another 2 8-week high intense classes, and you have 4 classes done for the semester. Potentially also for those that are still doing like courses in sequence, you could do the sequence like 2 courses in 1 semester instead of having to wait a whole year and all those kind of things. So 8-week, there's a lot of advantages. The downside is you have to be ready to invest the time and effort in it from the get-go. So I would just expect right now to put in 18 hours a week for this class. And I get that. It's a 3-credit class. The general rule is for a 3-credit class to expect to put in 9 to 12 hours per week total, including class time. We have 3 hours of class time. And it's double. So that means you're putting in 18 to 24. So you're probably going to spend 15 hours a week outside of class. I have a whole bunch of videos up. Watch through a lot of them MIT, which is really great, from the awesome linear algebraist who I absolutely love, Gil Strang. He just retired recently. I've talked with him and met him a couple times, but I also think that he has a lot of really good material that really benefits your book. As well as I've also taught this class online before, and so I took a lot of the videos I made for those previous times and I reused them. So some of the things that it's referencing, some other things, don't worry about that. Just look for the content and what's it teaching about how to use the content instead of the calendar items, because it's just, honestly, it's a pain to try to recreate a whole new videos every single semester. Couple of things I want to hit on. Sorry, this slide doesn't look great. Our class is using something called mastery grading. That means it's different than your other grading systems. Your typical grading, you have a couple tests and based on percentage, but the way it works essentially is I could do 0 homework, and if my homework's worth 20% of my grade, I could still walk out with 80% and get a B. That's not the way our class works. You can't really ignore, or you could, on a test, you can say, I don't really care about that concept. I'm only going to focus on this thing over here. Mastery grading goes back to those learning outcomes. It's about getting to making sure, but on the flip side, you have the semester to show that you can perform those outcomes. Whether you show those outcomes at the end of the semester or at the beginning of the semester, that doesn't really matter. It's just that you show them. So here are, for instance, the core standards. I sent out an email that had all the standards on them. Look at that. The core standards are Gaussian elimination, matrix operations, inverses, determinants, vector spaces, column, row, and null spaces, linear independence, spans, and bases, eigenvalues, and eigenvectors. So all of these are the core things that if you walk away from this class only knowing these things, great. But there's also supplemental standards that are often additional concepts rolled off of these and so forth. So it's not like you're going to focus on those. The grading is literally going to mean that you, to get A, B, or C, you're going to have to pass all of those, period. Not most, not some, all. The end. If you're missing one, it's a D. Yeah. So I would recommend that you study and perform as well as you can. Now, remember, I'm not grading you based on your arithmetic. I am grading you based on how well you can demonstrate your mastery of that specific concept. Again, we'll go over this in class and do some more things. Now, in terms of supplemental standards, those will determine how many you do of those, will determine how you do in terms of your A or B. Now, if you get all the supplemental standards but are missing a core standard, you're still down the D section. Please understand, core standards. Ooh. So I'd make sure those are done first, and then it's supplemental standards. And on top of that, we have homework throughout the semester. There's 13 assignments. You need to get a grade of at least 85% overall in that category in order to get an A, 75% or better to get a B, 65% or better to get a C. Again, just kind of play with it and think about these are scenarios. So the first thing I would check when I'm going through, honestly, through grading things, did they pass all the core standards? Yes or no? If no, you go down into the D category. Then I come down to the next thing. Have you passed all 6 supplemental standards? Yes or no? The answer is no. Well, actually, I come to, have you passed at least 3? If it's no, well, now you're possibly in a C grade. Now we're going to check your homework. If they pass, I then just go then to the homework grade and make sure it's satisfied. So if you pass all the core standards, let's say you passed all the supplemental standards, but you only have a 75% in your homework grade, you would still get a B. So I just want you to understand that's how the grading system works. Let me know if you got questions on it. Final things just to say, I recommend that you set up a regular schedule. Like, as intense and as fast as this is, you really need to have a personal schedule. I'm going to put in this much time. I mentioned 18 hours. Really, what I would do if I was you, I would plan to do 2 or 3 hours a day in your algebra. And I would space it throughout the day, Monday through Saturday. Maybe it's an hour and a half here and an hour and a half there. Set something up, write it down on a schedule, mark it out in your device. You guys all have devices. You're going to make that a priority. Make that your time and make it happen. Second suggestion, ask questions. The biggest way for me to know what you don't know is for you to ask questions. So if you're struggling with something and you're not really communicating well with me, I'm not going to know that you don't know, okay? So I need you to come and ask questions in class, and so forth. I am a big advocate. There's not really such thing as dumb questions unless it's literally something I answered like 2 seconds before. Unless, and even in that case, if you didn't understand what I answered, that might be the situation. If you weren't paying attention, that's a different question. Another one, just understand that failure leads to learning. I'd rather you instead be paralyzed by inaction to just step into something. And finally, come to class every single day. We're going to go through stuff that's going to be fast, but that class is an opportunity for you to process a lot of stuff you watch. We're going to do problems and get direct feedback, as well as that's an opportunity for you to pass those standards and continue. Let me know what questions you have, and I'll see you day 1.